Dear students, today we will discuss exponential function and logarithmic functions. After discussing those two, then again I will come back to problems on composite functions, that is the derivatives of composite functions. Okay. First let us look at exponential function. What is an exponential function? Say f of x is equal to a power x, where a is greater than 0 and a not equal to 1 is called an exponential function. A is any positive real number not equal to 1, then f of x is equal to a power x is called an exponential function. For example, 2 power x, 3 power x, 10 power x, etc. These are called the exponential functions. Okay. So in that, f of x is equal to e power x is called the natural exponential function, where this e is called the exponential constant whose value is approximately equal to 2.718. Okay, the value we can express one series, we can write a series expansion for this e power x. E power x is equal to 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial and etc. This is the series expansion of e power x. If I put x equal to 1, then I will get e power 1, which is e, that is equal to 1 plus 1 by 1 factorial plus 1 by 2 factorial plus 1 by 3 factorial plus 1 by 4 factorial and so on, whose value approximately will be equal to 2.718. This e is called the exponential constant. Okay. Now, at the x equal to 0, if I put x equal to 0, e power 0 is equal to 1. E power 1, which is around 2.718, then e square, which is the square of 2.718 and so on. Let us look at the graph of this function. Okay, the graph of this function. You observe, put any value for x, whether you take x is as positive real number or negative real number, e power x will always be positive. Okay, so you will understand better. Instead of e power x, if I take 2 power x. If I go on increasing the value of x, then 2 power x value goes on increasing. Put x equal to 0, 2 power 0 is 1, 2 power 1 is 2, put x equal to 2, you get 4, put x equal to 3, you get 8, put x equal to 5, you get 32, put x equal to 10, you will get 2 power 10, which is equal to 1024, and so on. Then, if I substitute negative values for x, then also 2 power x will be positive only. See, if I put x equal to minus 1, I am getting 2 power minus 1. 2 power minus 1 is nothing but 1 by 2. Then put x equal to minus 2, that will give you 2 power minus 2, which is 1 by 4. Put x equal to minus 3, 2 power minus 3, that's equal to 1 by 2 cube, which is 1 by 8. You will observe that it is positive for all real values of x. So the graph will look like this. This is the graph of e power x. At the 0, e power 0 is equal to 1. So this is the point 0, 1. Now as the value of x becomes lesser and lesser, in other words, when x approaches minus infinity, this e power x will approach 0. As x increases, the value of e power x also increases. Okay. So from this we can observe that the domain of this is the set of all real numbers. This function is defined for all real values of x. And the range is a set of all positive reals. Okay, set of all positive reals means open interval 0 to infinity. This is the domain of e power x. This is the range of e power x. Okay. Next, limit. There is one formula, that is limit of x tends to 0, a power x minus 1 by x is equal to log a to the base b. Limit x tends to 0, a power x minus 1 by x is equal to log a to the base e, which you have seen in first place. The proof of this is beyond the scope of your syllabus. Just remember this formula. Okay. So now, with the help of this, I would like to find the derivative for this exponential function. I want the derivative of f of x is equal to a power x. I want to find its derivative. Oh, so what do we do? By definition, f dash of x is equal to limit h tends to 0, f of x plus h minus f of x divided by h. That's equal to limit h tends to 0, f of x plus h. F of x is equal to a power x. So f of x plus h is a power x plus h minus f of x, which is a power x divided by h. A power x plus h minus a power x divided by h. A power x plus h. A power x plus h, I will write it as a power x into a power h minus a power x divided by h. I will take a power x as a common factor here. I will take a power x as common. Then you get limit h tends to 0, a power x into a power h minus 1 divided by h. This a power x is independent of h. Here we have h approaching 0. So a power x is independent of h. You can take that a power x out. So a power x into limit h tends to 0, a power h minus 1 divided by h. A power h minus 1 divided by h. That's equal to a power x into, look here. Here we have the formula, limit x tends to 0, a power x minus 1 divided by x is equal to log a to the base e. Now limit h tends to 0, a power h minus 1 by h. Limit h tends to 0, a power h minus 1 by h. This is nothing but log a to the base e. Log a to the base e according to this. Here you have limit x tends to 0, a power x minus 1 by x equal to log a. So similarly, limit x tends to 0, a power h minus 1 by h will become log a to the base e. So here we write that f dash of x equal to a power x into log a. In other words, derivative of a power x is equal to a power x into log a to the base e. This formula you have to remember. Derivative of a power x is equal to a power x into log a to the base e. Okay. So now with the help of this, I try to find the derivative of e power x. So what is the derivative of e power x? D by dx of e power x. That's equal to, this will become e power x into log e to the base e. So this is equal to e power x into log e to the base e. What is the value of log e to the base e? As we know, logarithm of any number to the same base is equal to 1. So log e to the base e is 1. E power x into 1 is e power x. D by dx of e power x is equal to e power x. Okay? So the derivative of e power x is e power x itself. Okay. So this is about exponential function. Now let us look at logarithmic function. Let a greater than 0 and not equal to 1 be any real number. A is any positive real number but not equal to 1. And b be any positive real number. Then we say that log b to the base a is equal to x. We say that log b to the base a is equal to x if a power x is equal to b. Log b to the base a is equal to x if a power x is equal to b. Remember, log is defined only, log b is defined only when b is positive. A should be greater than 0, a should also be positive and not equal to 1. Then log b to the base a, we call it as x, provided a power x is equal to b. For example, log 8 to the base 2 is equal to 3. Since 2 cube is equal to 8. Then log 32 to the base 2 is equal to 5. Since 2 power 5 is equal to 32. Then log 100 to the base 10 is equal to 2. Since 10 square is equal to 100. Log 8 to the base 8 is equal to 1. Since 8 power 1 is equal to 8. Then log 1 to the base 5 is equal to 0. Since 5 to the power 0 is equal to 1. In other words, see, from this we can say logarithm of any number to the same base is equal to 1. From this we observe that logarithm of 1 to any base is equal to 0. Because whatever the base I write here, its power 0 is equal to 1. So log 1 to the base 5 is equal to 0. Or we can generalize it that log 1 to any base is equal to 0. Okay. So now I would like to discuss some of the properties of logarithms which you already know and you have been using it in physics and chemistry. Okay, still let me explain. There are few properties of logarithms that I would like to explain. First one, log mn to the base a. This is equal to log m to the base a plus log n to the base a. Okay, I'll prove this. Let log mn to the base a is equal to x. I'll take log mn to the base a as x. This will imply that a power x is equal to m into n. A power x is equal to m. And meanwhile, I take log m to the base a as y and log n to the base a is equal to z. I have taken this as x, this as y and this as z. So by definition, if I write log mn to the base a is equal to x, this will imply that a power x is equal to mn. Log m to the base a is equal to y. This implies that a power y is equal to m, and from this we can write a power z is equal to n. Now I will consider this a power x is equal to mn. Now in place of m, I will substitute a power y. In place of m, I am writing a power y. And in place of n, I will substitute a power z. So a power x is equal to a power y into a power z. So a power x is equal to a power y into a power z is equal to a power y plus z. As you know, this is the formula. A power y into a power z can be written as a power y plus z. This implies, see here we have a raised to x is equal to a raised to y plus z. From this I can write that x is equal to y plus z. What is x? Log mn to the base a is equal to y, which is log m to the base a, plus z. Z is log n to the base a. Is the formula. So log mn to the base a is equal to log m to the base a plus log n to the base a. This is the first problem. Okay. Let us look at the second one. The second property is log m by n to the base a is equal to log m to the base a minus log n to the base a. Proof of this is very similar to the previous one. I'll take log m by n to the base a is equal to x, log m to the base a is equal to y, and log n to the base a is equal to z. So this will imply that a power x is equal to m by n. Log m by n to the base a is equal to x implies that a power x is equal to m by n. From this we can write a power y is equal to m and a power z is equal to n. Log n to the base a is equal to z implies a power z is equal to n. Okay. So now here we have a power x is equal to m by n. In place of m, I will substitute a power y, and in place of n, I will substitute a power z. A power x is equal to a power y divided by a power z. From there, I can write a power y by a power z is nothing but a to the power y minus z. This will imply that x is equal to y minus z. Therefore, x is log m by n to the base a is equal to y, which is log m to the base a minus z, that is log n to the base a. Log m by n to the base a is equal to log m to the base a minus log n to the base a. Okay. Let us look at the third property now. Log m power n to the base a is equal to n into log m to the base a. Log m power n to the base a is equal to n into log m to the base a. Proof of this. I'll take let log m power n to the base a is equal to x and log m to the base a is equal to y. I'll treat this log m power n to the base a as x and log m to the base a as y. Okay. So by definition, log m power n to the base a equal to x. This will imply that a power x is equal to m power n. And from here, we can write a power y is equal to m. Log m to the base a is equal to y implies that a power y is equal to m. Okay. So here, a power x is equal to m power n. In place of m, I will write a power y whole power n. A power y whole power n. So this is a power x is equal to a power y whole power n is a power n. A power x is equal to a power ny. This will imply that x is equal to n into y. X equal to n into y. Substitute. What is x? Log m power n to the base a is equal to n into n. I will give it as this. In place of y, I will write log m to the base a. So log m power n to the base a is equal to n into log m to the base a. Okay? This is the third property. Let us look at the fourth now. Log b to the base a is equal to log b to the base c divided by log a to the base c. This is also called change of base 2. Change of base 2. Okay. Proof. Log b to the base a, I have shown that it is equal to log b to the base c divided by log a to the base c. Let I will take this as x. Log b to the base a is equal to x. Log b to the base c is equal to y. And and log a to the base c is equal to z. Okay. So according to the definition, log b to the base a is equal to x will imply that a power x is equal to b, and from here we get c power y is equal to b, and from here we get c power z is equal to a. Okay, so now we have a power x is equal to b. From this equation, c power z is equal to a. I replace this a with c power z. C power z whole power x is equal to. From this equation, I can write that b is equal to c power y. Okay, so if I combine this, get c power z whole power x. C power zx is equal to c power y. C power zx is equal to c power y. This will imply that z into x is equal to y, or x is equal to y by z. X is equal to y by z. So we can write, what is x? Log b to the base a. What is y? Y is log b to the base c divided by z, which is log a to the base c. Okay, so log b to the base a can be written as log b to the base c divided by log a to the base c. Okay. Students, here it's not necessary that it should be c only. It can be any real number. The base can be anything. But these two should be same. These two bases should be same. We use this formula whenever we want to change the base depending on the need of the given problem. If we need to change the base, then this is the formula we use. So keep in mind that if you have log b to the base a, we write log b divided by log a and write the same base here. Whatever the base is, it can be log b to the base d divided by log a to the base d, or log b to the base e divided by log a to the base e in that. Okay. So from there, I said we can write any base, but make sure that these two bases are same. So if I am writing the base as b, then what happens? You just observe log b to the base a is equal to, I want to change the base. Instead of a, I want it to be in terms of b, suppose. Then I can write log b to the base b divided by log a to the base b according to this rule. So now, what is the value of log b to the base b? We already know that logarithm of any number to the same base is equal to 1. So log b to the base a is equal to 1 by log a to the base b. So what we observe here is that if I interchange these two, if I interchange a and b, then here I have to take the reciprocal. Log b to the base a is equal to 1 by log a to the base b. Okay? Then these are the four properties you should know. Now I explain the graph of logarithmic function. Okay, see the exponential constant e, if I take that as the base, log x to the base e, this is called the natural logarithms. Throughout this chapter, whenever I mention log x, you should understand that the base is e, and I am talking about the natural logarithms. And logarithms to the base 10. Okay, these are called common logarithms, which you are using for all practical purposes in physics and chemistry. There you are using common logarithms. Here we will be using natural logarithms, which is log x to the base e, which we also write as ln x, ln x we write, that indicates log x to the base e. Okay, so throughout this chapter I will just, whenever I write log x, you must understand, whenever the base is not mentioned, you must understand that the base is e. By default, the base is e, the exponential constant. So it is called natural logarithm. Now the graph of log x. This is the graph of log x. At the x equal to 1, it is 0, because log 1 is equal to 0. and this graph never touches y-axis. At the 0, I said while defining log b to the base a is equal to x, I mentioned that this b should be greater than 0. B should always be positive. Log b is defined only when b is positive. In other words, log x is defined only when x is positive. At the 0, it is not defined. It is defined only to the only for positive reals. Therefore, the domain of log x is the set of all positive reals. R plus indicates the set of all positive reals. Here base is E. Okay. Set of all positive reals in the domain, because only to the right side of x the function is defined. To the left side of x it is not defined. To the left side of y-axis it is not defined. It is defined only to the right side of y-axis. It is defined only when x is positive. And what is the range? The range is, see, it can go down from minus infinity to plus infinity. That is the range. Now in this, I will draw the graph of e power x also. E power x. This is the graph of e power x. Now you observe this curve log x, which is the image of this curve with respect to the line y is equal to x. If I write y is equal to x, this is the line y is equal to x. The graph of log x to the base e is the mirror image of the graph of e power x with respect to the line y is equal to x. The line y equal to x acts as a mirror. So this is the mirror image of the curve log x with respect to the line y is equal to x. So from this we can come to the conclusion that the inverse of log x is e power x and the inverse of e power x is log x. So e power x and log x, they are the inverse of each other. Okay. Now I would like to see what is the derivative of log x. I want to find the derivative of log x. Okay. So I will take let f of x is equal to log x. When I write f of x equal to log x, I mean log x to the base e itself. Then I want f dash of x. F dash of x is given by limit h tends to 0, f of x plus h minus f of x divided by h. That's equal to limit h tends to 0, f of x plus h. F of x is defined as log x. So f of x plus h is log x plus h minus f of x is log x divided by h. Okay. Now look at the numerator. In the numerator we have log x plus h minus log x. Base I have not mentioned here, so it is to be understood that the base is e. Okay. This is of the form log m minus log n. As we know, log m minus log n can be written as log m by n. So this will give us log x plus h divided by x. Divided by h. Log x plus h by x divided by h. That's equal to limit h tends to 0. H tends to 0. Log x plus h by x. I'll write this as log of 1 plus x by x plus h by x. H by x divided by h. Okay? I am splitting this as x by x plus h by x. X by x will give you 1 plus h by x divided by h. Okay. See now, there is one property of limits. There is one formula in limits. Limit x tends to 0. Log 1 plus x divided by x is equal to 1. Limit x tends to 0, log 1 plus x divided by x equal to 1. Okay? That formula I have learned in first PUC. Just remember this formula. Okay? Proof is not necessary. Limit x tends to 0, log 1 plus x by x is equal to 1. Now, I want to use that formula here. See, you have limit h tends to 0 here. Log 1 plus h by x divided by h. H by x is there. Here having x here, denominator also x, limit as x tends to 0. So we have h by x here, therefore we want h by x here. H is tending to 0, therefore h by x will also tend to 0. Here in the denominator, we want h by x, only h is present. So I will go for h by x into x. I am dividing by x, therefore multiplying by x. Multiplying and dividing by x. Now, as h tends to 0, h by x also tends to 0. Therefore, limit h tends to 0, log of 1 plus h by x divided by h by x will become 1. Okay, that x will remain as it is because we are applying the limit as h tends to 0, not x. So x is independent of that. So we get 1 by x. So from this we can write f dash is equal to 1 by x. In other words, d by dx of log x is equal to 1 by x. Okay, so among all the things what I have explained here, from exam's point of view, what is necessary is only this. D by dx of a power x is equal to a power x into log a, and d by dx of e power x is equal to e power x, and d by dx of log x is equal to 1 by x. These three things you need to remember from exam's point of view. Other proofs will not be asked in the examination. Okay, that I have explained here just for your knowledge. Okay, these three formula we should remember, which we shall be using in our next class. Next class I will solve. In the next class I will solve some more problems on derivatives. That is derivatives of composite functions. In other words, chain rule, problems on chain rule we will be discussing, where we shall involve these exponential functions also, exponential as well as logarithmic functions also. Okay, thank you.